Time travel, a recurring dream in the science fiction world so often visited by decades of comics, art, and film. We all have wondered about the possibilities of changing our past or staring into the future, but it is just not possible for us to do that, isn't it? Wrong? Well, perhaps. You see, we've all had this similar experience of time suddenly blazing so fast in some of our experiences, like that trip to the Caribbean, or playing that newly released video game all night, or even just spending time with your best pals under the starry night sky. Conversely, it seems that time seemingly just crawled on all fours when we grudgingly prepare for examinations, or that report you must submit by end of the week, or just trying to lose some weight at the gym. 1 minute never felt so long. Well, it's not that we have the capability to simply hop into a DeLorean and magically appear on a timeline that isn't originally ours. But it seems that we all have a power to influence how time feels for us, and it's not through the power of the time stone. This phenomenon is known as chronoception. Enter dopamine. It is basically a fancier name for time perception. So what is responsible for this perception of time? Turns out, it's just a tiny brain molecule. Its name? Dopamine. It's used to send messages between neurons and functions as a chemical messenger. In short, a neurotransmitter. It's a big part of our unique human ability to think and plan. It helps us strive, focus, and develop interests. This chemical molecule is the secret to how we all experience present time, how we remember our past events, and our view of future possibilities. Dopamine has been under the limelight lately, with many scientists actively wooing it for a while now. In particular, how it affects our sense of time. People suffering from Parkinson's disease and other related disorders have trouble telling time. They often have to go through life dependent on dopamine-boosting medication that mitigates these diseases. But this isn't something that only humans can do. Research performed on animals showed that they too perceive time differently, depending on the levels of dopamine in their brains. The nerdy bits. A study conducted in 2017 by Dr. Joseph Patton has proven that mice can behave as if time is ticking faster when their brain is stimulated by dopamine. Specifically, boosting dopamine slows down the animal's internal clock, leaving them underestimating the amount of time that has passed. What happened was that the mice were trained to perform a timing task. Some of the lucky ones were doped with dopamine-enhancing drugs. The drugged mice were able to respond to tasks quicker than those without, suggesting that their perception of time was sped up by the increase in dopamine. This also provided key evidence that could change how we view dopamine-linked disorders, one of them being attention deficit hyperactivity disorder, ADHD. People suffering with ADHD are often prescribed dopamine drugs to mitigate the effects of their disorder, one of which is impulsivity. Due to inadequate dopamine levels, people with ADHD are unable to postpone gratification. They sense time differently, and this makes delayed gratification much harder. Similar study was done on humans in 2018, where some subjects were enhanced with dopamine before performing a time perception task. The objective was to press the spacebar upon seeing an image on the computer screen. The study concluded that subjects under dopamine enhancement were more cognitively reactive in pressing the spacebar than those who received the placebo. Therefore, it's evident that higher levels of dopamine bestows people this ability of heightened time perception. Dr. Andrew Huberman, a renowned neuroscientist, explained this time perception effect. He describes it as fine slicing of your time bins, and it is akin to increasing the frame rate of your camera. For example, slow-motion movie scenes are captured by using very high frame rates, as though the same movie is now sliced more finely, allowing one to see every little detail from one frame to the other. With high dopamine levels, our brains overestimate how much time has passed, giving you the illusion that time is passing faster than normal. Conversely, serotonin molecule does the opposite, and our brains underestimate how much time has passed, giving the perception that time is passing slower than normal. So how does this affect us? These two chemicals play a huge role in our body clock, impacting our perception of time. He explains that your circadian rhythm, your body clock, plays a huge role in your dopamine levels, and therefore your perception of time. As you wake up in the morning, your brain is doused in dopamine, giving you that feeling of alertness and motivation that most people are familiar with after a good night's sleep. As the day progresses, dopamine levels gradually decrease and is replaced by increasing levels of serotonin. During this stage, your brain underestimates how much time has passed. One productivity hack is to rearrange your working day schedule to take advantage of the high dopamine levels in the morning. Strategically perform the most difficult tasks or assignments early in the day instead of pushing it towards the end of the day. The sense of accomplishment for completing those tasks then becomes a positive feedback loop that pushes you to complete even more of such difficult assignments. If dopamine is the answer, how can I get some? Is there any other way to obtain dopamine other than a good night's rest? Well, there are many other ways that can give you a boost in dopamine levels, such as having a nice meal at your favorite restaurant, tasting a glass of your favorite wine, looking at your Instagram post going viral, and even having sex. This is psychiatrist Anna Lemke, and she explained that every one of us has a dopamine release baseline. When we engage in certain activities, our dopamine levels go up or down, depending on the behavior or the substance we're ingesting. This explains why some people enjoy roller coasters while others absolutely hate it. Researchers tried to quantify the amounts of dopamine released during pleasurable behaviors. Consuming chocolate, on average, will cause a 50% rise in baseline. Sex is likely to cause a 100% spike. Amphetamines, a class of drugs that includes meth, sends dopamine levels approximately 1,000% above the dopamine baseline level. And as a result, this extremely pleasurable experience completely disrupts a person's capability to function at all, other than wanting to get their next drug hit. People who are addicted will just stop doing the activities they previously enjoyed, as no other activity can send them to that out-of-this-world experience. Application. The consequences of drug consumption are brutal, and it hurts not just the drug abusers, but also the family members around them. Excessive gaming, social media obsession, and pornography are all associated to disruptions in their baseline dopamine levels, similarly to drug addictions. It is evident that there is a direct link between dopamine's role in our body towards one's personal motivation. What if we can leverage this connection to learn how to accomplish our goals in a beneficial way? It turns out we can. Professor Mark Lepper, psychologist at Stanford University, conducted a famous experiment on two groups of children who liked to draw. One group was given a reward after drawing, while the other group wasn't. Eventually, they stopped rewarding, and the kids who were rewarded were much less likely to draw on their own compared to the ones who didn't receive rewards right from the start. It turns out that the presence of a reward system undermines the rewarding feeling from the work itself and makes us less inclined to perform hard work in the future. This is also known as intrinsic or extrinsic reinforcement. So, contracting for a reward to do this initially interesting and attractive activity subsequently had a negative effect on their interest. The usage of unnecessary rewards undermined intrinsic interests, turning an attractive activity into something the child would only want to do if there was a payoff. The act of giving a superfluous reward to ourselves sabotages the activity because we associate less pleasure with the activity itself. As dopamine is released from our brain while receiving a reward, it lowers our dopamine baseline, resulting in our brains thinking that we performed the hard work because of the reward and not because we genuinely enjoyed it. This severs our dopamine system from the activity, and time seems to slow down drastically, and even developing a sense of dread while performing the activity. Furthermore, with the reward at the end of the activity, we experience dopamine famine during the activity itself, which adds to the difficulty of carrying out the task. The solution is to find ways to enjoy the activity alone. Despite all the discomfort, pain, and difficulty, remind yourself it is worth it and pleasurable. Over time, the brain associates pleasure to the effort of completing the task and releases dopamine during the activity. This then helps to increase energy and focus, reducing the reliance on rewards or stimulants to do it. Because of how dopamine alters your time perception, time will just fly right by. Keep in mind the sense of pleasure and enjoyment during feelings of intense effort, and eventually it will become subconscious to you. When that happens, you will find yourself capable of completing any difficult task without feeling awful.